Hello everyone and welcome back to our Rust for Beginner series. And in today's video we are going to cover some very important topics. Okay, you might have heard about it but haven't fully understood yet. So today's concepts are lifetimes, methods, associated functions and traits. So all are very useful concept in Rust and very important concept. Okay, so we'll start by diving into lifetimes and we'll understand what they are and why they are critical for memory safety in Rust. Okay, so and after lifetimes we'll move on methods and associate function and then on traits. Okay, so okay, let's start. So Rust uses lifetimes as a compile time feature to ensure all references remains valid. Okay, so like a lifetime is used to check the validation of any reference pointer. Okay, so you can think of lifetime as a expiration date for references. Okay, they help the compiler guarantee that no reference outlives the data it points to, thus preventing dangerous dangling pointer. Okay, so what it means is it will just check for the lifetime. It will check for the lifetimes of any variable or any reference. Okay, well write one example and try to understand understand in better way. So let's look at a simple function example that finds the longer of two string slices. Okay, so this is one function. A function name is longest and this is the lifetime, how we define lifetime. So this is a is a lifetime. Okay, so this is lifetime syntax and we have two variable, one is x, one is y. Okay, and this is a return type. Sorry, this is a data type of the x, that is reference of str. Okay, so this is string type and this is our lifetime syntax and this is also lifetime syntax. Okay, and this is return type. So this is structure of return type and same we are using lifetimes here as well. Okay, and yeah, this is comment section. The lifetime A indicates that the returned reference will live at least as long as both x and y. Okay, so if you notice, this is lifetime A, this is also A, this is also A. So okay, and this is also A. That means this x, y and this return type, this return value, all the lifetimes are same like a. Okay, so all three lifetimes are same. So this is what it is saying: the lifetime a indicates that the return reference, so this is the return reference. Okay, so the return reference will live at least as long as both x and y. Okay, got it? So yeah, and this is just a simple calculation, like condition: if x dot length, that is this string dot length, is greater than y dot length, then x, otherwise y. Okay, this simple example. uh, Let me copy this and just and I will paste the code here, okay, and then I will try to explain. Okay, so this is just simple function longest, and this is the syntax of lifetime. This is how we add lifetime to any functions. Okay, so this is lifetime functions, and this is x and this is y, both are parameter, and the parameter type is of str. This is also a string type, both are string type, and this is a lifetime. So both lifetimes are same. The lifetimes of x and lifetimes of y are same lifetimes. Okay, and the return type is also a string type. So the lifetimes of this string is also same, that is a. Okay, so both three lifetimes are same. Okay, and this is a main function where we define one string 1, and this is string 2, and this is result variable, and we are calling the longest function. Okay, and we are just passing two strings, that is x and y, and then again we are printing the value of result. Okay, let's try to run this. So the longest string is hello Rust. Great. Now let's move to explanation part. The lifetime annotation a after function, this is okay, function longest declares a lifetime parameter. Okay, so this is syntax, this is how we declare lifetimes. Okay, the parameter x, that is string, reference string, and y tells the compiler that both reference must be valid for at least the lifetime a. Okay, this ensures that the returned reference is safe and cannot outlive either input. Okay, so until this input x and y is valid, the returned reference is also valid, because all the three lifetimes are same, that is a. And now let's see an example with struct that hold a reference. This show how lifetimes tie a struct field to a lifetime of an external data. Okay, so let me just copy the code. So this one struct important exalt lifetimes is a, and part. Okay, this is a field part, that is part, and it holds the reference of string. Okay, this is the main function. One string text, and it has some text like Rust makes system programming safe and unsafe, safe and fun. Okay, and this is our first sentence, another variable, and we are just splitting text. Okay, and then we are creating a new instance. Okay, so create an instance of important that borrow from text. Okay, so we are just creating new instance of this struct. Okay, and we are just passing creating a new instance using this first sentence variable. Okay, so we are just doing this, and we are just printing the variable dot part. Okay, so this is struct dot field name, this field name, and this is part. And then if we print, so Rust makes system programming safe and unsafe. So this is a simple concept of lifetime. Okay, So let's try to understand and using explanation part. So the struct important exert lifetime a has a lifetime parameter a. Okay, here we have lifetime a for this struct, meaning the filled part is valid as long as the data it borrows is valid. Okay, and this prevent any chance of using a reference after the original data is dropped. So this is the main reason behind lifetime is like if we borrow any value, if we borrow any value, then it should not live longer than the original data. That means if original data is dropped, then the reference should not be valid. So this example illustrate how lifetime works for many simple cases. Rust lifetime elision rules let you omit this annotation, but when you need precise control or when multiple references are involved, you add them explicitly. That means in simple cases, you don't need to define lifetime in your code. Rust compiler will automatically detect and solve the problem, but in more complex case you need to add lifetimes manually in your code. So the next topics is methods and associated functions. Okay, so methods are functions defined within an IMPL block, that is implementation block, and are associated with a specific type. Associated functions, so this is methods, and these associated functions are similar, but they don't take self parameter, making them ideal for constructor. So here is an example. Let's consider a struct that represent a rectangle and add some methods to it. Okay, so there is one struct name is rectangle, and there are two element, one is width and second one is height. Okay, so this is simple struct we know, and this is the IMPL of rectangle. This is implementation of rectangle. Okay, so the first function is function new, which is a constructor which take two argument, one is width, second one is height. Okay, and it return the self, that is instance of the rectangle itself. So it is returning rectangle of two elements, width and heights. So we didn't add semicolon here like this because this is return statement, and we know in return statement we don't need to write semicolon. Okay, so this is implementation for rectangle, and this is first function and this is second function to calculate area. Okay, to calculate area, and it takes self, itself, reference of itself. Okay, and the return type is u32. So this is area, we will calculate area using self means this rectangle dot width and self dot height. So we'll multiplying both and returning u32, that is width multiplied by height. Okay, and the third one is function name can hold. Okay, so it is taking two argument, one is uh, reference of self and another one is other rectangle. Okay, reference of other rectangle. So it will return true or false, that is boolean values. Okay, so this is just like uh, comparison, like self dot width is greater than the other dot width, or and this end operator, and the self dot height greater than other dot height. If it true, it will return true, otherwise it will return false. Okay, so this there is another method called function double size. Okay, uh, it is taking one mutable reference. That means it can alter the value inside this self. Okay, so we know it holds two parameter, one is width and another one is height. So here what we are doing is we are just doubling the value, which width and height. So we are just multiplying by 2 and here multiplying by 2. Okay, so we are just changing the data of width and height. That's why we use here and mute, that is reference mutable. Okay, and this is our main function, and we are just creating one mutable rectangle object, and we are just passing 30 and 50, and here it is new function. So from where it comes from this new method. So this is same new method. Okay, so we are just first initialize the instance of this, then we just call uh, this new function. Okay, and what this new function will be, this function will return the new instance of the rectangle. Okay, so this is a new instance of the rectangle struct. Okay, and we are just printing the area of rectangle, that is rect dot area. It is area function is same from this area. Okay, and then we are just creating a other small rect object. So this is rectangle and the same new functions, but here if you focus, this is 20 and this is 40. Okay, in here previous size is dimensions are 30 and 50. Okay, so we are just printing this can hold small rectangle or not. So if these values are small, then it will return true, otherwise it will return false. So in this case it will return true because 20 and 40 is smaller than 30 and 50. Okay, so then again we are just passing the reference of small rect into this function can hold, and the next function is double size. That means we are altering the value inside this function. So uh, println new area and rect dot area. So let me copy this. Okay, let's try to run. What's happening? Okay, my internet connection. Wait for some time. Okay, so now let me run. Okay, so the output is area 1500, that is area. So rect dot area. So the inputs are 30 and 50. So how we calculate area? We just multiply both the values. So 30 multiplied by 50 is 1500. Okay, and the next output is this can hold a small rectangle, then the values, the return value is true from this, because the 20 and 40 is smaller to this value 30 and 50, that's why it is true. And we are just doubling the size using these functions, so we are just printing new area, that is 6000. Okay, so we are just doubling the area using this formula, self dot width multiply by 2, that is 30 multiply by 2 60, and again height multiply by 2, that is 100. 50 multiply by 2, that is 100, so 100 multiply by 60 is 6000. Okay, so this is a just a small example. Okay, so let's quick recap. So this is just a simple struct. Okay, and this is implementation of this rectangle, and we are just defining a few functions inside this. And this one more concept, we need to compulsorily initialize this or use these methods in order to make it compile. Okay, so whatever function we are defining inside this impl block, we need to call in main function. So yeah, so this is just a simple example. Okay. And so okay, and the next topic is trait. So trait, what are traits? So trait define a set of methods that types must implement. Okay, similar to interfaces in other programming languages. So where we just create a function, we don't define a full uh, logic inside the code, inside the function. We just define a body of the uh, function. So this is similar like interfaces in other programming languages. Okay, so it allows for polymorphism and code reuse. Okay, and it enables writing generic function that work with any type. Okay, mark this, enable writing generic function that work with any type implementing a given trait. I will give an example of this, like how it will work with any type that implementing a given trait. Okay, so this example, let me copy this first. Okay, and now let me copy this as well. We need this code as well, because the functions are used inside this new code as well. So we need to make it, we need to copy this rectangle, implement rectangle block with area function. Okay, we need to add this as well, we'll add later. So let's copy this, let's copy this as well. Okay, so hmm. So this is just a simple our previous example. One struct rectangle, 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 and this implementation block with four methods. One is new, area, can hold, double size. Okay, so this is just a um, previous one, and we are creating defining a trait. Name is summary. Okay, so this is a trait. We need to use this keyword. Okay, so this is summary trait, and we are just defining the um, syntax and return type of the function. We are not defining the in actual logic like this. We are not defining actual logic like self dot weight or anything like that. Okay, we are just defining the syntax and body of the function summarize. Okay, and what we are doing is we are just implementing summary for rectangle. Okay, so this is for this rectangle trait, and the one function we need to use compulsory is summarize, that is inside this summary trait. Okay, and function summarize, it will take reference of self. Okay, and return one string. So this is same uh, string. Okay, and like, yeah, just this is just a format macro, and the strings is rectangle with an area of. So self dot width, we are just printing the values of width, height, and area. Okay, and there is one another struct. So this is example. Okay, so there is another struct, article, and there are three child, headline, author, and content. Okay, and we are doing same. We are just implementing this summary trait for this article as well. So implementing summary for article, and same summarize function we need to use, and we are just you know printing this headline and author name. Okay, and okay, so like, in order to print, let me check. Okay, so here we are just using this inbuilt FMT display trait. Okay, so implementing the standard display trait for rectangle for pretty printing. Okay, I will show you with example. Okay, so this is just inbuilt display trait. We are just implementing same for rectangle. There is inside one function, that is fmt. This is for formatter. Okay, just printing just writing the rectangle with width and height. Okay, and this is the main function. So we are excuse me. Okay, so this is just new instance of rectangle. The value is 30 and 50, height and width. Okay, so just printing rectangle. Okay, here we are printing rectangle uh, and printing summary, react dot summarize. We already have this summarize function. Okay, here for article as well, for rectangle as well. So we are just calling this function. Okay, and again like same we did for rectangle, we are doing it for article as well. So for headline, author, content. Okay, so three string, and we just create a new instance of article and just print article summary, article dot summarize. So same we have summarized for article as well. If we can check, okay, summary and function summarize for this article as well. So let's try to run this, and let me, so here is a output rectangle. So let me pull it down. So this is the output rectangle. This is rectangle 30 by 50. Okay, and summary. So this summary rectangle 30 multiplied by 50 with an area of 1500, and this article, print article summary, this is what it is, Rust, the future of system programming by John Dye. So this is author name and this is the headline. So we just like if you scroll, so here it is rectangle 30 by 50 with an area of and 1500. Okay, and this is the okay, so let's try to understand this, why we need to implement this standard display trait for this rectangle. Okay, so here if you can see, so this is the print function, print macro, and we are just printing rectangle. Okay, so here we are printing rectangle, but rectangle is this is instance of a struct, and we can't print this struct using this simple formatter. Okay, so we need some special kind of display formatter, and Rust provide one inbuilt formatter, that is display trait. Okay, so let's try to just comment this. Okay, and let me try to run this. So here it is showing one error. Okay, what error it is? So it is showing that println you are trying to print rectangle instance. So it is showing rectangle cannot be formatted with a default formatter. Okay, so this is a default formatter and we can't format the rectangle instance using this simple formatter. Okay, so what it is saying, the trait standard fmt display. Okay, so you need to implement display trait for rectangle. Okay, so if I uncomment and run it, it will definitely run. Okay, so this is an example. So this is just example of trait, how trait work. Okay guys, and let's okay, so here is some explanation. So defining a trait, we define the trait called summary that require any type implementing, okay, to it to have a summarize method. We define a trait called summary that requires any type implementing it to have a summarize method. And implementing a trait, we are just, as we know, we just implemented a trait using impl. Okay, we implement summary for both rectangle struct and a new type article struct. Okay, polymorphism with the summary trait, You can define write function that accept any type that implement this trait, making your code more flexible. Okay. Okay, and this is a display trait. As we discussed, we also implemented the standard library display trait for rectangle. This lets us use this formatter in our println macros to print a friendly description of a rectangle. So traits are powerful way to write generic and reusable code. They allow different types to share common behavior. So this is important. Okay, they allow different type to share common behavior, and they are essential in building abstraction in Rust. So okay, now when to use this concept. Okay, so what is the use case? So let's quickly recap. First, lifetime. They ensures that reference never outlive the data they point to. For many simple cases, Rust infers lifetimes automatically. In more complex scenarios, especially when returning reference or when multiple references are involved, you may need to annotate lifetime explicitly. And another one is method and associated functions. Use thus to add behavior to your types. Methods operate on an instance, while associated functions are used to create instance without a self parameter. And the next is trait. They define shared behavior across different types and allow for polymorphism. And mm, understanding this concept will help you write more modular, reusable, and safe Rust code, as we know. And this is just a conclusion. What today we cover lifetimes, data types, custom data types. Okay, and yeah, that's all what we explored today. Is okay. So I encourage you to type out this example yourself. You can go official documentation of Rust. Okay, for more examples, and please modify them and experiment with your code. And if you have any questions or need further clarifications, please leave a comment below in comment section. And if you found anything helpful, please don't forget to like this video, subscribe for more Rust tutorials, and please like. And thank you guys, thank you.